numerical analysis, historical construction, etc. He has published more than 100 papers in international and national journals or conferences, more than 85 reports, and 11 books on earthquake-resistant design and construction, guidelines for confined masonry, structural design and detailing of confined masonry, EWS houses, and good construction practices. He has filed 4 Indian patents. So far, he has guided 5 PhDs, 40 MTechs, and 60 BTech students. He developed spinners, tool for design of RC slabs and beams for residential buildings, and documentary on confined masonry, which are most widely referred document in construction sector. He was pioneer in establishing Building Dynamics Laboratory, Construction Technology Demonstration Park, and Advanced Pseudo-Dynamics Laboratory at CSIR CBRI, having capability to test full-scale buildings up to 4 stories under quasi-static condition. Also, as a nodal officer, led the team of CSIR Mission Mode project on mass housing, delivered significant output, aligning national mission, housing for all, and lighthouse projects on emerging technologies for housing. He has done many collaborative and sponsored industrial projects for industrial and strategic sectors. Notable of them include those funded by IGCAR, BARC, NTPC, NDMA, Airport Authority of India, IOCL, BPCL, Navodaya Vidyalaya Samiti, Ministry of External Affairs, fertilizer plants, ports, etc. He was instrumental in post-disaster rehabilitation of Kedarpuri at Kedarnath. Presently, he is the team leader for post-earthquake reconstruction of education and health infrastructure in Nepal under Government of India funded projects, improving disaster resiliency of lifeline building in Himalayan region, makeshift hospitals for COVID-19, SHM of Central Vista and Kalwa Bridge, and many more. Has organized for practicing engineers on earthquake construction, repair, and national and international conferences in the domain of his research areas. He is a member of Building Committee at several institutes, Post-Earthquake Reconnaissance Team, NDMA, and Bureau of Indian Standards. He is a member of ISET, ICI, IE India, and several other professional bodies. He was secretary of ISET Journal for the year 2013 to 2017 and visited several countries in connection with R&D program like Taiwan, Portugal, Canada, Myanmar, and Nepal. He is an organized person with a strong technical expertise, leadership, partnership development, problem-solving ability, result-oriented approach. Moreover, R&D in structural engineering is his passion, focusing on technological solutions to nation and society at large. On personal side, Dr. Chairasya is a humble, polite, down-to-earth gentleman and a social activist too. On behalf of the coordinators and participants, I cordially invite you, sir, for this session.
Thank you, ma'am. Hello. Hello.
Yes, sir. You're audible.
Am I audible? Am I audible, ma'am?
Yes, sir. You're audible.
And my slides are visible now. Shall I proceed?
So the slides are not visible now, sir. Please share.
My slide is not visible?
No, sir.
I have already made. Oh, shall I do the screen sharing again?
Yes, sir. Please share the screen.
Yeah. No, stop sharing. Now, is that my slides are visible now, ma'am?
Yes, sir. Now it's clear, sir. Yes, sir.
Yeah. Shall I start now?
Yes, sir. Please start.
Thank you so much, ma'am, for your kind introduction. Thank you so much once again. Good morning, everyone, for sparing your valuable time and participating in this particular lecture on confined masonry, or I should say, I will be more focusing on a very pertinent topic, that is on sustainable retrofit of masonry buildings. Before I begin a formal presentation, I would like to sincerely, humbly thank to the organizers, particularly Dr. Anjali, Ms. Radhika, Dr. Beena, and other organizing committee members, and the LBS College of Engineering uh, for inviting me for this a very important event. And I will put my all efforts to convey the little limited experience what I have in this particular topic, on that is on the seismic resistance of masonry buildings, particularly with the emerging trend on confined masonry. So before we start our this discussions in the right spirit, I would like to bring your kind attention that we are nowadays facing one or the other disasters every day. Every day we have 3-4 disasters in our baskets when you talk about country as a whole. Apart from the COVID-19 pandemic, we have rainfalls, landslides, seismic events, and that too, the events are happening at non-expected regions. Like in Hyderabad today, the earthquake was there. Like the locations where earlier the drought used to happen, now it is flooding. Earlier where it was too cold, there too hot season is being witnessed. So this is all, I should say, it is inviting all of our attention is on the climatic change, because based on this today's news events, when you see, never before in human history have so many people, population is again a question mark, known so much about risk so large that was never experienced together. But I have experienced this type of seismic event as such in personally when I was in Nepal, when twin earthquakes happened. So climatic change promises to bring all this negative impact, in my opinion, and our cities are not simply comprising the physical placed buildings and roads, but it is a complex social and legal relationship. The designing for resilience is not simply a technological problem, but it is a generations of opportunity by how well we redefine problem of individual, community, public, private, legal, to create much more vibrant and interesting complex city to accommodate the strains which are being rose to us by different events. So when you talk about the climatic change, so and in view of all these disasters, first and foremost important thing what we are losing is life, loss of life, thereafter the properties, and the economic losses and recovery losses. Means whatever the disaster is happening, whether it is an earthquake, landslide, rainfall, drought, flood, tsunami, so on and so forth, everything relates to the losses in terms of life, property, economic losses, and response time. And the philosophy of earthquake engineering in particular says that we should not allow any loss of life, moderate loss of property which can be recovered or retrofitted or repaired, and in the shortest possible time, that is called as a recovery time. And during the recovery or retrofitting stage, you should incur as minimum as possible expenditure, at the same time minimum time as well, so that the intended purpose of that particular facility, whether it is a residential building, hospital, schools, or any infrastructure, should be economical. So economic losses should be economic losses means business losses should be minimized. When you see the trend of global deaths from natural disasters in entire last decade, one can see that we have lost around 185 lakhs of populations, which is at the rate of 1.5 lakhs per year globally. Means the death rate, whatever we are mentioning, that philosophy says that we should minimize, but we are not. 1.5 lakh per year in disaster loss of life is not a comfortable sum for me. In the similar fashion, when you see the number of disasters which are happening over the, again, last century, so they are having an increasing day by day, increasing trend day by day, and in recent times it has rose phenomenally. In addition, the business loss cost is also incurring to a large extent, and we should focus on reducing all these things. And that is where we can jump into that climatic change, which is making the things more difficult and rising uncertainties. And we have to think differently, so that the recovery time, loss of life, loss of property, and economic losses, business losses should be minimized or should be made zero. And that is pose a question to us, that can we have, or can we build a disaster resilient infrastructure, and which should be resilient, safe. And if you are, and for that purpose, this particular event or this lecture or this program series is very pertinent things, and which will convey you that if you are strong, you can embrace the sustainability in your life, community, organizations, that you can confine the future you are looking for. You can create the future and ecosystem you want to live in. We have all the solutions on our fingertips, just need the courage. And if we engrave innovative sustainable solutions, we can mitigate the impact of next disasters. So all the participants are a very good ambassador for all of us to pass on the information, whatever has been told in this particular program, to the next generation, that is budding engineers, that is your students. So with this, again, the disaster is challenge. That is, we will definitely, there will be an exponential growth on the population. There is increasing trend in disaster, more exposure of infrastructure with time because of developments are happening. Now we are moving from developing to developed country, and lack of enforcement building codes, which is very, very important. So these things, keeping these in perspective, we have to focus on our disasters. And in this particular topic, I will be more focusing on the earthquake disaster as such. Over and above, while dealing with on earthquake or seismic events, I will be having more focus on masonry buildings. So whenever we have any event, earthquake event happening, so there are common type of modes of failure: in plane failure, out of plane failure. Failure mechanisms will be different, and most oftenly we should see the damage of structural members, non-structural members like hoardings, parapets, so on and so forth. And that is basically cause of concern. That is basically putting pressure on us in terms of loss of life, property, so on and so forth. And then that's why there is a need to understand these things in particular very firmly, and as entrusted to me the responsibility to take over this particular journey with you on masonry buildings as such. Masonry buildings, when you talk about, are very important for all of us, because when you talk about our country, we have 301 millions of existing building stocks as per 2011 census. This is likely to increase by around 20% further if we have again a census on 2021. But when you see the statistics, around 85% of existing building stocks comprises of masonry buildings. And masonry buildings are well known for their collapse or extreme failures in case of earthquake events. Whenever such events are happening, if we talk about a simple typical damage pattern of rural housing, you will come across the similar kind of failures after the earthquake. The failures may be the collapse of parapet, collapse of roofing, separation of wall, shear cracks or diagonal cracks, or out of plane failure of at mid length of long walls, then wall cracking, then vertical cracks at the intersections, corner failures, so on and so forth. So these are the different typical damage pattern which we normally witness after any event, earthquake event in particular. When you talk about the masonry, which looks to be very simple, very well adapted, and we are very accustomed to adopt this particular technology in our day-to-day constructions, but it is posing more of challenge. It looks like to be simple, but from engineering perspective, it is highly challenging for all of us because it is a heterogeneous material. It comprises of masonry units, mortar, and reinforcement. When masonry units are stacked one over each other in an array, connected with or jointed by mortar, maybe of different material, mud, lime, cement, lime, so on and so forth, then it gives birth to a masonry walls, and combining all the masonry walls together, it gives a masonry buildings. Ideally speaking, the seismic resistant features which normally has been recommended by our Indian standard IS 4326 2013 is we need to provide the horizontal bands to give integral box actions at plinth level, lintel level, sill level, roof level, cable ends, and eaves level, so on and so forth. So basically, the purpose of providing lintel band is to create the integral box action of entire building, and one has to be very careful in providing this, that this band should be provided at one particular level connecting all the walls together, which is creating an integral box action in the buildings, and based on its location it is named as the plinth, lintel, sill, roof, or gable bands. When you are constructing masonry buildings in seismic prone region, seismic zone 4 or 5, then in addition to the horizontal bands, we need to provide the vertical reinforcement, corner vertical reinforcement at all the intersections along the openings as a jam, and that is basically providing the deformability in our building systems and improving the ductility of masonry buildings. Having said this, if we see the motivation, so on this particular study that is on the confined masonry, is that the around 85% of existing buildings in our country are masonry buildings, which are heterogeneous in terms of material properties. It is the material properties when we talk about the units. It is the properties are also varying from place to place, like our accents in our country from north to south and east to west. The strength of units is also changing. The mortar is also changing its property because it is all depends on the locally available ingredients and construction practices. Then with this, the vulnerability of the masonry buildings has demonstrated very badly in past, and that is basically posing us to look for appropriate technology which is cost effective, seismic resistant, which can make use of locally available construction materials and skills. So for that purpose, we have to look into the appropriate technological solutions alternative to the masonry buildings, but it could be a masonry because it is the choice of the each and every one of us in our country. When you talk about the damage in the masonry buildings, when to begin with, the in 2001 earthquake of Bhuj, total collapse were noticed in most of the masonry buildings and excessive damage in some of the buildings. And it is not like that the RCC buildings could has sustained very efficiently in our country or in abroad. They also gone into lot of damage, into even in the collapse because of poor construction practices. That means I want to mention that if you are saying that RCC buildings are robust and they are very good from resisting the earthquake events, it is not so if not constructed properly, whether it is a RCC building or masonry buildings. So before going further in understanding this or understanding or great insight of seismic activity in masonry buildings, let us try to understand the masonry wall first. And it is my duty, and I will also tell the takeaway for this lecture, or you should convey to your students also, that whenever you are dealing with any kind of a problem or issues or a subject, you should first of all focus on how this, what things go wrong while in this particular things. Try to identify such wrong effects and then try to strengthen yourself, your project, your activity, your work in that direction. In the similar process, I would like to mention, when you are talking about the masonry buildings, let us try to consider a masonry walls and understand what are the seismic, what will happen to this masonry walls when it is subjected to a seismic events or ground shaking. So particularly whenever any masonry walls is considered, so what could be the modes of failure? How can it fail? When you see this masonry walls, when it is subjected to lateral loading, there are alternative four options or likelihood that it can fail. For the case one is due to dilation, in which axial load is very less, and because of poor bond between the mortar and the units, under even a small shaking, there could be a separation between the mortar and the units, and which may lead to the increase in the volumetric increase in the masonry walls, and as a result, dilations may take place. So this particular mechanism is very well explained in this particular photograph. You can see in this is the masonry building with very lightweight roof at the, and as a result, when it is gone under shaking, the separation of masonry units and mortar happen. So that is leading to volumetric expansion of the masonry wall. That is called as a dilation. Another mode of failure could be the sliding. In this particular case will happen when there is an excessively large amount of axial load and at the same time good unit strength but poor strength of the masonry mortar, and as in this case there could be a possibility of sliding of different masonry courses one over each other, and as a result sliding of entire wall and in turns the masonry building. In certain cases, when there is a high amount of axial load and a good moderate strength of your units as well as good strength of your mortar, in this case there could be a possibility of diagonal crack, and that cracks widens at the mid half of the wall and it is marching towards the corner, and it may happen that it may lead to the uplift. So that kind of mode of failure called as a diagonal or shear cracking or rocking and uplift. So these are the widely four seismic modes of failure of the masonry walls due to the earthquakes. Now, having known this mode of failure which might occur in any masonry building, why not to try to learn something from the nature as well? You can see in this particular photograph. In this particular photograph, some masonry building was there, very old, maybe 200 years old, and with time, tree has grown up and it has confined or embraced entire building from all sides. And as a result, if I take a bulldozer even and put a lateral thrust on this, the masonry building will not going to have any kind of a collapse or a damage. Why not to borrow this particular mechanism from the nature and put it in our day-to-day system of construction, particularly the masonry buildings? By making, instead of peaks, we can make use of a lightly reinforced RC element, that is RCC element, that is a column, tie column or bond beam. That can be very well explained from this particular slide. If you have a wall panel, which is masonry wall panel, which is subjected to the lateral loading at the ground or ground shaking at the bottom. So possibility of dilation when you talk about may happen, or any kind of a distress mechanism as explained in the previous slide can happen. If the same wall panel, if I take and if I embrace this wall panel from all the sides, from all the four sides particularly, with the lightly reinforced RC element, which is vertical element, can be called as a tie or tie column, and horizontal element is called as a bond beam. So these confining elements, which confines, embraces entire masonry panels from periphery, and when it is put to the ground shaking at the bottom, at the base, what will happen? This kind of a failure which you see will not happen, and like most of the time, what will happen? There could be a cracks or excessive damage or crushing of the concrete and bending of the reinforcement in the confining RC confining element. As a result, the masonry will have very minor damage and collapse is prevented. And this kind of a concept can be borrowed in our day-to-day construction of masonry buildings, which is giving a birth to the confined masonry. And this particular confined masonry is being followed worldwide, including India, unknowingly. But now there was a need to understand its engineering perspective, its behavior, and that is what the devotion in have been made at CBRI. With having known the certain good and bad thing about the confined masonry. When you see the confined masonry all over the globe, when it has been exposed to various kind of earthquake events, whether it is Latin America, Europe, South Asia, Far East, it has performed exceptionally good if built properly, and that has instigated me to take this particular R&D activity at CBRI. At the same time, it was also noticed that when confined masonry were exposed to even extreme event like earthquake having more than 7 magnitude, it has performed exceptionally good, uh, and that's why when constructed adequately, properly, as it has been explained from this particular presentation. There were very good performance of confined masonry worldwide. You can see from this particular picture, even particularly in the Chile earthquake in 2010, having the magnitude of almost 8 plus, all the other masonry buildings and other type of even RCC building collapsed, damaged extensively. But you can see the white building which was still standing. That was the confined masonry properly constructed. But at the same time, in some cases, the confined masonry also gone into excessive damage if not constructed properly, if not honored the basic principles of construction of confined masonry. So there were mixed reactions, there were mixed results. But and for that purpose, we need to have this detailed investigation on this particular subject. When you talk about the masonry, particular and comparison of confined masonry with the RCC moment resisting frame structures. So what you see when the RCC frame structures, in which basically the RC columns and beams are constructed first, then masonry walls are laid at appropriate locations without any adequate connectivity between the masonry and the RC element. And when it is subjected to the lateral loading, shaking, then what is happening? Because these RC elements, that is RC frames, RC beams and columns, they goes under bending, and as a result, there is a separation in the masonry walls and the RCC frame that is leading to a gap at the corners and creating the compression strut and damages in the masonry walls. In contrast, when you see the confined masonry, in which what is the construction of the sequence and all those things, I will come to that later. But the failure mechanism will be, since the confined masonry is constructed simultaneously, construction of masonry walls and RC element are done simultaneously and with the good bond between the masonry and RC element, and it is embracing all the sides. And when it is subjected to a lateral load, there is no possibility a gap to be created at the corners or at the interface, and that's why it is both jointly resisting the lateral forces, and no significant bending in tie column and tie bond beam is noticed, and that is giving birth to a robust kind of masonry at a lower cost. So it is so one advantage of this alternative construction technology, that is the confined masonry, is that once it is constructed, it looks like similar to the RCC frame building, but it is relatively very, the sequence of construction matters, but the cost and other aspects are relatively less, but very good seismic performance, or even more seismic performance than the poorly built RCC frame structures. So you can construct the confined masonry even for 1 story to up to 4 to 5 story in even seismic prone region, seismic zone 4 and 5. Why I'm comparing this RCC confined masonry with the RCC frame building, which is called as a high-tech building. High-tech, why? Because it makes use of steel, concrete, formwork, walls, and so on and so forth, and with good structural design concepts. But and everything is that whenever you are providing the steel, it should be placed on the right place, the right quantity, right quality, properly tied together, and with proper cover and embedment. Similar thing is with the concrete and formwork. But when you go to the field and see in practice, whatever has been desired by the theoretical aspect, you will never find at site, and everything is nose. That is basically leaving a birth to the vulnerable RCC building or poorly built RCC building. In RCC structures, the construction of sequence of construction matters, in which I mentioned that first the frames are constructed and then masonry works is done as and when where required, and that's how the RCC frame with masonry infills acts on. But there is a slight difference in the confined masonry. In this, first of all, the reinforcements are erected at appropriate locations, then masonry works is done at certain location up to certain height. Once the masonry work is done up to a certain height, maximum 1 to 1.2 meters, and then the shuttering is provided at the two faces and concrete is poured. And as a result, the entire masonry work is embraced by lightly reinforced RCC element. And why I'm saying lightly reinforced, because you don't have to calculate the reinforcement as per the procedures given in the tie column or bond beam, as per the provisions given in IS 456 or other RCC building design codes. So that's how you can achieve a good bond between the masonry and the tie column. So once such type of buildings are constructed, it looks similar to this particular building. So it is neither a masonry buildings nor a RCC frame buildings, but it is called as a confined masonry buildings. And what are the different components involved in the confined masonry buildings? Vertical elements are not called as a tie column. Horizontal elements, that is called as a bond beam, and the masonry and it is provided at the plinth level and lintel level. When you are providing the RCC slab, in that case the bond beam provision is not required, and all these bond beams should be resting on the brickwork, obviously, because the sequence of constructions demands that. And definitely, while as I mentioned earlier, that reinforcement is erected first, and then you are doing the masonry works and leaving the groove at the ends. That grooves basically ensures the better bond between the RC element or concrete and the masonry works. When you are dealing with this grooves, one has to be very careful that the groove should be limited to maximum 40 mm. That is because if it is given more, then you cannot do proper compaction, and it may lead to honeycombing. And that's why 2D, that is the size of the aggregate, should be considered as a limiting factor. So the grooves may be ranging from 25 mm to 40 mm in this fashion. And then once the masonry work done up to certain height, after leaving the groove apart, then provide the shuttering and pour the concrete, and that's how you can achieve the better bond between the masonry and the RC element. If you do not wish to give the grooves and you are giving the plain edges, alternatively you have extensive reinforcement bars which are considered as vestige when it is having less than 400 mm. Then in this case, such bars can be provided at every fourth course which can be embedded within the mortar, passing through the tie column, and then that's how it is providing the good connect between the two adjoining masonry walls through the tie column. As a result, you can achieve a better bond between the masonry and the tie column. Masonry, I mean two adjacent masonry walls and through the tie columns. So this could be an alternative way to the grooves. And again, in this you are making use of waste material, so the cost of construction cannot increase. Only the sequence of construction and slightly increase in the workmanship is needed. So basically, what one has to keep in mind whenever you are planning for construction of any building, confined masonry in particular, you have to provide this columns, that is tie columns, at all the corners, at all intersections, and whenever the length of such walls is increasing more than 4 meters at this location, you have to provide this tie columns. The tie columns minimum dimension could be the equivalent to the thickness of the wall. Minimum thickness of wall can be kept as 120 mm, that is 4.5 inches for up to 1 story. And if your number of story increases, then again the thickness of your masonry walls need to be increased. Again, that depends upon your compressive strength of your masonry units and the mortar and construction practices. Again, another parameter one has to be considered in terms of the stiffness of the masonry, confined masonry buildings. So whenever you are dealing with such masonry wall panel, the h/t ratio, h is the story height to the thickness, t is the thickness, should be less than 25, and or otherwise L/t, length of the wall panel divided by thickness, should be less than 25. If it is an unreinforced masonry or reinforced masonry, in that case this L/t and h/t ratio corresponding values are 18 as given in our code IS 4326. So these are the one of the check you need to do. So in summary, when you talk about the construction of confined masonry walls, it should be done with the good quality of building materials in terms of and good workmanship. Tooth edges are required, as I mentioned, less than 40 mm. Alternatively, you can provide the horizontal dowels, and the concept of other general conditions of your construction practices for masonry buildings need to be adopted. So this is how you have to provide the shuttering. Once the two walls, masonry walls, are constructed up to certain height, maximum 1.2 meters, then provide the shuttering at the two edges and pour the concrete. Other detailing, minimum reinforcement required in the tie column is 4 10 mm dia bars. Similar is the case for the bond beam, also 4 10 mm dia bars, and the lateral ties in the columns and stirrups in the beams could be the 6 mm dia at 100 center to center at the ends and 200 mm center, 150 mm center to center at the mids. That is basically from confinement point of view, ductile detailing point of view. Further, the detailing of ductile detailing as given in our IS 132920, that is the bending of the hooks by 135 degrees, the length of the hooks, all these things stands here as well. Again, one important thing when you are dealing with the confined masonry construction, the connection between the tie beam and tie column, the reinforcement of tie beam should pass through the tie column, longitudinal reinforcement of the tie column. That one has to be ensured. It should not so happen that the reinforcement of the bond beam is lying outside the longitudinal reinforcement. That is again a dangerous catastrophe. In case of seismic events, concrete cover get collapsed, and there could be a poor bonding between the bond beam and tie column. So to avoid this, if it is better practice that the reinforcement in the bond beam should be taken through the longitudinal reinforcement of the column, and over and above, if you can provide additional dowel bars having a leg length of minimum 50 times the diameter of the bar, can be provided in this fashion, which will basically providing a Caesar kind of phenomena between the two perpendicular walls, creating good connectivity between two perpendicular walls through the tie column.
Now
Now, to have a better understanding on the behavior of the confined masonry, I would like to share a small video which will broadly tells you, give the confidence in understanding how the confined masonry walls and unreinforced masonry walls, or even the RCC frame structures with masonry infill behaves. So
Now, we're going to be comparing the behavior of three different structures. In the middle, we have unreinforced masonry walls. On the left, we have confined masonry walls, which are made up of individual masonry units, confined around the edges by representative reinforced concrete elements. On the right, we have a moment frame, which is made up of the representative concrete elements alone. Now, keep in mind that the reinforced concrete beams and columns of a confined masonry system tend to be sized much smaller than those of a concrete moment frame system. So, while we'll see the system acting as a moment frame, the small size of the members will give it a relatively low capacity. Let's shake these structures in plane. We start to notice hinging in the moment frame where the flexural demands are greatest. It's important to note that though the moment frame here is yielding first, that doesn't mean that a concrete moment frame can't make a good lateral system. It just means that the beams and columns need to be adequately designed to do so. That would mean sizes larger than the typical 15 and 20 centimeter beams and columns of a confined masonry system, as well as other special measures. In the unreinforced masonry system, we see diagonal cracks forming, shortly followed by the complete disintegration of the masonry wall. In the confined masonry system, we also see diagonal cracks forming in the wall. As the wall deforms, these two corners pull apart from each other, causing tension. As we know, masonry alone is weak in tension. Similar to the unreinforced masonry system, we see cracks develop. However, the confining elements postpone the complete disintegration of the wall. In a related note, when the wall corners move together, a compression strut forms, which is an important mode by which the seismic force at the roof finds its way down to the ground. As we can see, it is the combined action of the compression strut in the wall and tension in the confining elements that allow for strut and tie action, which provides a complete load path from the roof to the ground. We're going to be looking at the role of the ring beam in the out-of-plane behavior of a confined masonry wall. Let's say that we have a structure with a lightweight roof made up of a simple rafter and purlin system, which, unless it's specifically designed to do so, won't provide adequate out-of-plane support. So for our purposes here, we'll ignore the roof altogether. We'll take this fairly regular setup here and shake it in the longitudinal direction, which is this direction, and we'll keep an eye on these two walls, which are identical except for one thing. This front wall has a ring beam on top of it, which will help to restrain this wall out of plane along the top edge. The rear wall here does not have this ring beam, so we can make a pretty good guess as to which one will fail first. Just as we might have expected, the wall without the ring beam supporting its top edge failed first, and we can thus conclude that the ring beam plays a crucial role in the out-of-plane stability of a confined masonry wall. Now let's take a look at that unsupported wall again from a different angle. From this freeze frame, you can see cracks forming roughly in the pattern of an upside-down Y, starting near the midspan of the unsupported top edge. Of course, a ring beam would have helped to prevent this failure.
So with this, I hope that you have understood the concept, mechanism, and behavior as a whole, which the confined masonry panels So before now, I will quickly highlight the some design steps. One has to be very careful while deciding the confined masonry construction. You don't have to go to a very meticulous design procedures. So first of all, some of the parameters which one has to check or cross check depend is called as a wall density, spacing of the two walls, type spacing of the columns, h by t ratio and L by t ratio I have mentioned, and then you have to ensure the proper connect between the non-structural elements like parapet wall, gable ends, and walls with openings. Special attention need to be paid, and then to toothing at the wall to tie column. So these are the important provisions one has to see while dealing with the confined masonry. When you talk about the wall density, which can be defined as the total cross-sectional area of all confined masonry walls in one direction divided by the sum of the floor plan area of all the floors in a building. So to have a more explanation on this particular figure is quite uh, easy to understand. So in this case, you can see all these white color boxes. These are represents the walls in one particular directions. Intentionally, the walls in perpendicular direction have not been shown. When you talk about the cross-sectional area, if AW is the cross-sectional area of all the walls, which normally is being taken at the sill level at the ground story, because that is the most vulnerable locations when you are dealing with uh, maybe 2, 3, 4, or 5 story building. And because at that location you encounter minimum cross-sectional area of the walls in any direction. And in contrast, AW is the light sky blue color. What you see that the plan area or total floor area. So ratio between the AW by to the AP gives the wall density, and you have to limit your wall density ratio between 2 to 2.5. Again, it depends upon the seismic zone in which you are planning to construct your confined masonry buildings. In seismic zone 3, 4, and 5, the suggested wall density could be 2, 3, or 4.5%. Apart from this, the other planning and design concepts which need to be embedded in the construction of confined masonry includes the simplicity and symmetry of your buildings in both plan and elevation. In plan, irregular shapes are discouraged, and regular shapes are expected to perform better. If you are dealing with the irregular shapes, in that case you need to separate or make these irregular shapes into a regular shape, like the way you can see in this particular picture. Similarly, this was as regards to the plan is concerned. When you deal with the in elevation, you should not deal with very slender buildings and should be avoided. That means the h is the height of the building and b is the width of the building. H by b ratio should be less than 4. Inverted pendulum type buildings are unstable. They should be avoided. It is again the abrupt change in the sudden change in the stiffness should not occur, and for that purpose this kind of a construction should be avoided. If at all you need to do it, you can provide or you have to provide adequate separation gap after breaking these buildings into a regular one. Further, the regular building plans, as I mentioned, is always good in when you are constructing the confined masonry buildings, because that ultimately improves the seismic performance of the building as a whole. Apart from that, the building length to width ratio, that is the aspect ratio, is a very important parameter in which the again the L by W, that is the length of the wall, length of the building, and the width of the wall should be less than the 4. And one has to deal and take into consideration that whenever such parameters exceed, whenever the aspect ratio increases than 4, you have to provide the adequate separation gap between the two blocks. You have to break the entire building into two pieces, give the separation gap, and that separation gap can be calculated as per the provisions given in IS 1893 2016, or that is the maximum displacement have sum of the maximum displacement between the two buildings. As a thumb rule, you can consider that 20 mm per story of the building should be considered as a separation gap. If you have 4 story, then minimum gap should be 80 mm, for example. And another important thing you need to consider about the wall layout. So walls should be placed uniformly, symmetrically in both the directions in plan and elevation, and because if you are placing your walls in unsymmetrical fashion, then it may attract the more torsional effect. And note that in this particular that it is not always possible to have perfectly symmetrical wall layouts, but one shown in the on the right on the of this particular figure is not ideal, but much better than the layout on the left side is expected. So you should have a better layout of your buildings in plan and elevation. Similarly, you should not provide just to fulfill the demand of aspect ratio. You should not provide the wall density or wall layout in only one direction. It should be symmetrical in both the directions. In the elevation, also the wall should be one over the other. Floating walls or unsymmetrical walls placements should be discontinued because it is leading to inadequate seismic load path. Means the seismic forces which are forces which are created because of the inertial forces at the roof level, then it is transferred to the wall up to the foundations. And when this kind of a discontinuity in load transfer mechanism, then it is leading to the inadequate seismic load path. So this kind of discontinuous walls should be avoided. Further, the openings should be as far as possible should be symmetrical in different along the height of the building. It should be one over the other. It should not disrupt or discontinue your bond beams. So location of opening should also be given a very good attention. Further, the when we are dealing with the sloping roof or pitched roof, in that case you need to provide the gable ends, the bond beam in terms of a gable roof band or gable end if required, or if it is a good practice that unnecessary placing the masonry in the gable ends will again attract the more inertial forces and leading to more possibility of overturning, collapse, something like that. So to avoid this, alternative is that you can place or cover such regions by means of a lightweight gable panels, roof type panels or roofing sheets. About the good practices, I have already mentioned that the reinforcement of your bond beam should be passing through the longitudinal reinforcement of tie columns with, if not possible, if you are not assured, then if there are certain constraints of, as you have seen in this particular picture B, in this case you can provide additional dowel bars for that particular intersections. The dowel length should be minimum 40 times the diameter of the bar on each side. And but one thing you need to know, that the continuity of the reinforcement need to be ensured. Sometimes it may so happen that at the bond beam and tie column intersections, the bending of the reinforcement from bond beam or tie beam to the tie column is not possible. And in this case, alternative to that, ideally speaking, you should do the bending of reinforcement by LD plus 10 dB. But if in case you are not able to do it, in that case a U-shaped clips can be provided having the length of each leg minimum LD plus thickness of the wall, so of each leg. So this U-shaped clips can be a good alternative in while dealing with such kind of a constraints at site. Then general confinement detailing, as mentioned earlier, has to be followed in reinforcement confinement in bond beam as well as the tie column. Having known these basic concepts and provisions laid in the codal provisions for construction of the confined masonry. I will take your journey to the experimental investigations which has been investigated, because till now whatever we have seen, we are not confident unless and until we do certain experimental investigation and develop our confidence. So for that purpose, we are consistently dealing with the full-scale experimental investigation on masonry buildings. We have started our journey since 21, and till now we have conducted extensive experimental investigations on the full-scale masonry buildings. In fact, to begin with, unreinforced masonry in 2001. Then, after its testing, the building size was 3 meters by 3 meters in plan with 3-meter height, without any earthquake-resistant measures. Once after the testing on under quasi-static test condition, the building was damaged. Then it was retrofitted by alternative means by providing MS flat as a lintel level and corner vertical reinforcement by chasing, and the efficacy of retrofitting techniques were carried out. Subsequently, we have again tested in 2005 the full-scale reinforced masonry buildings. The reinforcement detailing was carried out as given in our Indian standards IS 4326. Upon its testing, again the retrofitting was carried out, and then we have started our investigation into the confined masonry in 2013, and after construction of the confined masonry building, based on the procedures which has been discussed by now, a full-scale investigation was carried out. And in this presentation, I will be focusing on this full-scale investigation on confined masonry buildings. The data which was acquired from this particular investigation was basically utilized for development of guidelines. Upon testing of the confined masonry, the building was damaged. Again, it was retrofitted by a sustainable material, locally available material, low cost, low technology, low cost, low skills involving approaches have been evolved and retrofitted. So that aspects now I would like to show, discuss with you in the subsequent slide on the confined masonry. So this is how the journey on confined masonry started, as I have explained. And again, one most important challenge that we have a normal habit to borrow the results which from the literature or from the international community, but that is not a right approach, particularly in terms of masonry. The reason behind is whenever you are dealing with the stress in the masonry, particularly in the compression, as I mentioned earlier, masonry is comprised of the units, that is a brick or any kind of a bricks and mortar. So when you are dealing with the masonry which is available in the Western condition, Western world, the masonry units are quite stiffer than the mortar. As a result, the modulus of elasticity of the bricks is much more higher than the modulus of elasticity of the mortar. As a result, when it is subjected to uniaxial compression, the units are subjected to biaxial tensile stresses, while the mortar is subjected to triaxial compressive stresses. In contrast, when you see the scenario in Indian perspective, where we have mortar is quite stiff and masonry units are relatively flexible, and in this case, the modulus of elasticity of the brick is quite small as compared to the modulus of elasticity of mortar. And in this case, when it is subjected again the compression, the stressed conditions involve triaxial compression stresses for units and biaxial tensile stresses for the mortars. So these are the basic stress distribution things which puts a challenge in front of us, and for that purpose we have conducted a detailed investigation on units and the mortar and how the units are placed when we are constructing walls. So extensive work has been carried out at CBRI on prisms. When the prisms are constructed as per the provisions given in again IS 4326, the masonry prisms were subjected to loading perpendicular and parallel to the bed joints, and the response was captured by means of a data acquisition systems. And but apart from that, when you are dealing, masonry walls are dealing with lateral loading, it is come across with the shear strength, shear stresses. And for that purpose, it is very important to know and have an understanding about the shear stress in the masonry. And for that purpose, we have conducted extensive investigation on by conducting diagonal shear stress test on the wallets of 690 by 690 mm size, having a thickness of 230 mm as per protocol given in ASTM 519. Based on the detailed investigations performed on the prisms and the wallets, the data was captured and the linear regression analysis was carried out to establish the relationship between the mortar strength and the modulus of elasticity of the masonry. So based on that, after conducting various investigations and comparing the data which is available worldwide and in Indian scenario and perspective, the relationship drawn was the EM is equals to 456 times the FM, where EM is the masonry modulus of elasticity of masonry and the FM is the masonry strength. Now it is very important how to calculate the masonry strength, which is a very, again, a challenging aspect. It is not as simple as that of the concrete. For that purpose, in the concrete, normally you go and extract the concrete core and then carry out your investigation to know the in situ concrete strength. But it is not applicable in masonry as such. And for that purpose, we have again, what you can do at the most, you can take out certain brick units from the building or existing buildings and then mortar samples and calculate their strength. Having known the strength of the bricks, that is a FB, and the compressive strength of the mortar, FM, we have conducted the extensive non-linear regression analysis on the data and thereby derived certain constants K, alpha and beta, and try to explain, try to establish the relationship between the prism strength, that is the masonry strength, and the brick strength and mortar strength using these factors. And this particular exercise has again given rise to the development of equation, which is FM is equals to 0.422 into FB to the power 0.69 into FM to the power 0.25. This particular, based on this investigation, these equations have been embedded within our IS 1893-2016. And one can, an advantage of this particular exercise was having, you cannot always go and conduct the prism test or wallet test. So having known the compressive strength of units and mortar, which can be identified or obtained very easily, you can establish the or assess or estimate the masonry strength. So this is very, very beautiful value addition contribution which was made by our efforts in Indian standards and for the engineering fraternity at large. So as I mentioned that we have conducted extensive retrofitting investigations on unreinforced masonry. So this is how the unreinforced masonry, which was after testing, it was damaged, then it was retrofitted by providing MS flat at lintel level and corner vertical reinforcement, apart from the stitching of the cracks and grouting of the cracks. Now I will be focusing on the experimental investigation on a full scale, which was carried out the confined masonry. The sequence of construction, which is again, I would like to reiterate on this. For conducting this investigation on a full scale, we have constructed confined masonry buildings having a plan dimension of 3 meters by 3 meters with height of 3 meters. At all the 4 corners, the tie columns having a reinforcement of 4 10 mm dia bars were provided. Apart from that, the 6 mm dia lateral ties, 100 center to center at the ends and 200 center to center at the mid. After this particular bond beam was provided and it was anchored to the heavy testing floor adequately to represent as a foundation system. Then the masonry walls were constructed up to 1 meter, leaving the groove apart at the ends. When the 2 perpendicular walls have been constructed, provided the shuttering in this fashion and poured the concrete. After when the concrete was poured, immediately a brick was inserted and it was taken out to provide the shear key between the concrete and the between the between the concrete which was recently poured and the subsequent concrete which will be casted at the later stage. This is the picture which shows the typical grooving of 40 which was given a toothing which has been provided at the tie column and masonry interface. The procedure was repeated, and as a result, complete confined masonry building was constructed. Upon constructing the complete building, it was ready for the testing, and for the testing, we have provided the lateral loading at the roof level, as the inertia forces are generally acting at the roof level, so where the mass is more concentrated. Hence, the actuators were mounted at a roof level, and the loads was applied from the roof actuator which is coming from the single point, and it was distributed at 8 different locations by means of a specially designed relay system mechanism, what you can see in this picture. And the same same mechanism was provided on the other side, and it was connected properly by steel sections to provide the laterally increasing cyclic loading increment under displacement control. So, and as I mentioned, that we have conducted the quasi-static test under a very low frequency. This is the very good test in comparison with the shake table, having advantage in terms of that we are applying the test loads in an incremental increasing displacement control loading, and at a very slow frequency. So that is giving a very good time to me during the test to seek the observations of this particular building in terms of the damage pattern, how the damages are propagating, and how the different components are behaving. And this is also giving sufficient time to acquire the data and analyze the data holistically. To acquire the data, the sensors in terms of LVDTs, strain gauges, dial gauges have been provided at different critical locations, and the data was acquired by means data acquisition system, and it was subsequently analyzed. Once the data acquired, then the analyzed data was specifically utilized for drawing the load displacement curve, which basically gives the information about the initial stiffness, maximum loading, maximum lateral loading, maximum lateral displacement, ductility, energy dissipation capacity, through the hysteresis curve, which we normally get out of this particular test. So in this particular slides basically shows the comparison between the all types of tests which we have carried out since 2000. So the unreinforced masonry, reinforced masonry, and confined masonry. After which the RET, REP, you can see the unreinforced masonry which was repaired, reinforced masonry after retrofitted. All these tests have been performed, and which has shown that the confined masonry has exceptionally performed better in terms of lateral load resistance, maximum lateral load resisted by the similar geometry and material properties of the masonry buildings, with only the different typologies are there. So that is a very good platform base we have created for having a good comparison between the different type of building systems, that is a URM, RM, and CM, which showed that confined masonry has resisted 152 kilonewton lateral load and a maximum displacement of around 54 In contrast, when you see the unreinforced masonry, in which the maximum load resistance was hardly 32 kilonewton and displacement was 10 So, and similarly, the initial stiffness was also quite good, quite large as compared with the unreinforced masonry and reinforced masonry. So, in short, when we conclude and compare the results, that it gives confidence that the confined masonry are promising technologies, which enhances the seismic performance by small interventions. Like anything, basically it makes use of locally available construction materials and skills, and it is very cost effective, which is increasing the strength and ductility by around 342% and 429% as compared with the unreinforced masonry, and could be considered as a promising construction technology for upcoming masonry buildings across the country. Now, after conducting this test, this confined masonry building was damaged extensively, but not collapsed. And now it was again a challenge in front of us how to retrofit this confined masonry building. Although its performance was very good, beyond the provisions which has been given as per the performance-based design requirement of in the codes. But still, it was a challenge how to further make use of the damaged buildings or into service or into use. So this is a very important study what we have focused to address the issue of existing masonry buildings which are masonry buildings or distress in conditions, and how to improve the seismic resistance of existing masonry building stocks. So for this purpose, definitely there are right technologies available, but we want to rely on alternative materials which are locally available, economical, and does not attract more skills in implementation. So for that purpose, we have opted for 6 different options. One is the welded wire mesh GI, then chicken mesh, then the nylon mesh or mosquito mesh what you normally come across, then the industrial geogrid mesh, then polypropylene bands, and lastly was a very innovative idea that whenever you are conducting any construction, then you are utilizing cement. After use of cement, you are throwing those bags. Instead of throwing those bags, you collect those bags, stitch them, and put a hole of 50 mm by 50 mm in this grid fashion, and let us have the strip width of around 25 mm and stitch, and that ultimately gives rise to the plastic cement bag mesh. Again, a waste you are utilizing to weld. So all these options, we have alternative options we have tried to adopt for the retrofitting of this building. And for that purpose, again, a detailed investigations was carried out. All these alternative materials were utilized for strengthening of unreinforced masonry prisms and wallets. Prisms have been again taken having the size of 220 mm by 410 mm, again as per 4326 provisions, and the masonry wallet 670 by 670 as per ASTM 519. One control specimen was one set of control specimen was created of both the options. Control specimen means unreinforced masonry, and different sets have been created using all these different options, alternative materials. And whatever the embracement or jacketing using all these different materials which was carried out on the masonry, unreinforced masonry prisms or wallets, have been then plastered, embedded within the plaster of 1:4 cement mortar, and it was subjected to uniaxial compressive loads to understand the compressive strength and stress strain behavior and damage pattern. The axial load was applied at the rate of 4 kilonewton per minute, very slow axial load, and this is the typical damage pattern which was noticed. Basically, the spoiling of the plaster, separation of the plaster, and the alternative material jacketed material, and in few cases the crushing of brick units also have been noticed. Again, the response was measured in terms of load and strains and deformation. So, and the comparison was made by means of a compressive stress strain curve for masonry prisms for all different alternative options, which has shown that unreinforced masonry has a very poor compressive strength, masonry strength of around 3.2 MPa. In contrast, the wallets after retrofitting using plastic cement bag or a welded wire mesh jacketing has given enhanced the compressive strength by 6.2 MPa and 6.2 MPa, 6.1 MPa respectively. So that means the plastic cement bags and welded wire mesh has performed exceptionally good as compared with the unreinforced masonry and other alternative options, and could be considered as approach for strengthening or improving the compressive strength of the unreinforced masonry buildings, walls, or wallets. Further, the investigation was carried out to assess the shear strength of the masonry by using a protocol given in ASTM 519 by conducting diagonal shear tests on masonry wallets. Again, apart from the control specimen, all these 6 different options were again carried out, plastered, and tests were carried out. The response was measured by means of strain gauges, LVDTs, which were provided perpendicular to the direction of the loading. The results were again plotted between shear stress and shear strain. The results showed the similar kind of trend as we have seen in the compressive stress, that the substantially good enhancement in terms of shear strength has been noticed in case of a welded wire mesh and plastic cement bag mesh in comparison with the control specimen and other alternative options. Based on that, again, it has given a strengthened us that yes, in terms of in this preliminary things, we have enhanced the strength of masonry substantially using the plastic cement bag approach, jacketing approach, and why not to adopt this particular approach for further investigation and retrofitting of damaged confined masonry models. The basic reason for choosing this option was the properties of plastic cement bag mesh in terms of compressive strength, high compressive strength and shear strength after jacketing, flexible, economical, reusable, non-corrodable, minimum thickness, adequate bonding with masonry, and with this, keeping these features in mind, then the further investigations was performed. Before going into this investigation, again in the masonry, I would like to mention that most of the times you have to re-engineer or innovate the things. In the South India in particular, when you see the burnt clay brick unit, we have performed this entire exercise using the burnt clay solid brick units as units. But in South, the compressive strength of units is relatively very less. So hardly it is between 3 to 4 MPa, which is desired by the code. If you are coming across with the large amount of round boulders, the way you can see, you can make use of these round boulders in construction or in manufacturing of your brick units as well. In this, what you can do, you can consider the round boulders of 40 to 60 mm size, embed this in 1:8 cement mortar, have a mortar content of 60%, round boulder content around 40%, and around 5% cement content, and make and this is how you can put this particular mortar and then embed 3 to 4 stones in this particular heart of this particular units and in the mortar, and then do the vibro compaction technique. Using this compaction technique, you can manufacture the brick units using round boulder mortars embedded within weak cement sand mortar. When after doing this particular exercise, we have had a comparison of different options of units, that is burnt solid clay brick units, autoclave aerated concrete AAC units, and the RBM units of equal size if given. And when you try to extract the engineering property in terms of water absorption, compressive stress, dry density, modulus of elasticity, Poisson's ratio, shear strength, shear modulus, everywhere we could observe the innovations has taken its edge apart from the cost aspects. So this particular RBM units has substantially good engineering properties as compared with the burnt solid plate units and AAC. Apart from the cost, there is around 40% reduction in the cost of the units, and that's why it could be a very techno-economical solutions and to utilize these units for the construction of masonry buildings instead of solid burnt clay brick units. Again, you will be, by doing so, you will be putting lot, you are minimizing impact on environmental aspect from environmental sustainability aspect in construction process. Now, I would like to take your journey to the strengthening of the damaged confined masonry building. So this is the building which was damaged after the, this was the confined masonry building which was damaged after conducting the test as described so far. Upon doing so, the cracks were again, a cement slurry was grouted within the cracks, and the stitching of the cracks by plaster have been carried out. And subsequently, the entire damaged building was provided with the application of plastic cement bag mesh on all the sides in both the direction. It was pasted. It can be pasted either by means of epoxy or by nailing, and it can be embedded within the plaster of 1:6 cement mortar having thickness of 15 to maximum 15 mm thick. Upon doing so, again, this is the retrofitted confined masonry model. Again, the similar experimental protocol was applied to conduct the test on this particular model, and at the higher loading, we could see the damage pattern which was seen in the confined masonry in terms of the cracking, spoiling of the, in terms of the damage. We have normally seen the cracking, which is generally starts from the corner of the openings in the in-plane wall, and it is marching towards the corners, and these cracks are passing mostly through the mortar joints. Sometimes it is passing through the masonry units also. At the higher loading, the crushing of the concrete at the toe region and bending of the reinforcement in the longitudinal reinforcement of the column take place. So this is the typical damage pattern which was noticed after the retrofitted confined masonry model was put under lateral displacement controlled cyclic loading under quasi-static condition, that means under a very low frequency. So this type of the crack pattern which was observed was similar to the crack pattern which we normally see after any earthquake event occurred in realistic state. So we could achieve the realistic scenario through the experimental investigation by adopting proper experimental protocol, and the damage, the data information was recorded in terms of deformation strains by LVDTs and strain gauges, and the data thus collected was analyzed and put for the comparison. Again, in this particular graph, we have plotted the graph as against the load displacement curve for all kinds of masonry which were tested even after retrofitting. So this includes the URM, RM and confined masonry and their corresponding repaired and retrofitted models, which clearly shows that there is a significant improvement in terms of lateral strength, stiffness and ductility by 22% to in terms of lateral strength and ductility, and stiffness enhancement by 15% even after retrofitting of a damaged confined masonry model. In addition, the increase in the lateral strength by around 422% as compared with the unreinforced masonry model was noticed. In this case, the confined masonry retrofitted model has attained a maximum loading of 192 kilonewtons as against 34 kilonewton for URM and 152 kilonewton for confined masonry. Similarly, the maximum deformation capacity which was attained in the confined masonry, retrofitted confined masonry model was around 74 mm. In contrast, 54 mm in CM and hardly 9 mm in URM. So that again built up a confidence that the good comparison has been seen in terms of strength, stiffness, ductility, energy dissipation capacity, and uh, other injury, damage pattern, which was again giving a total confidence on confined masonry, on the retrofitting technologies, retrofitting techniques which we could evolve through this experimental investigation. So now quickly I would like to take the pictorial view of how the construction of confined masonry is to be done. This is a promising technology from engineering perspective. At the same time, it is again providing advantages in terms of vertical and lateral expansion. So in this picture, you can see a simple plan of a EWS, economically weaker sections house, with all detailing, and at the planning stage we have provided the tie columns at appropriate locations as per the provisions which was discussed in this section. And in this case we have provided the under-ream tile foundations, 300 mm dia pile, 3 meters long, since the construction has to be proposed on a black cotton soil, and there was a, so again it was secondary channel. So the P1 represents the pile locations and the pile caps, and GB is the grade beams which are provided at the plinth level. Subsequently, the tie columns, this pink C1, you can see these are the tie columns which were provided at all the corners, intersections, having a size of 230 mm by 230 mm, and wall thickness is all again 230 mm. The columns are provided with 4 10 mm dia bars, and the other reinforcement detailing as discussed in this particular lecture. This is the typical detailing which was provided for the piles, pile cap, tie column, and bond beam. And these, in addition to that, around the openings, instead of providing the tie column, we have provided only two 10 mm dia bars and hooks of 8 mm at 1.5 center to center, the way you can see, again from cost reduction consideration. Further, the other detailing what has been discussed has also been taken into account. So, and afterwards, the construction was carried out in the similar fashion as it was discussed. Then RCC slabs 115 mm thick was again provided to provide ease in designing of the RCC slab, which is a very typical, which can and we want and we wish that RCC slabs can be designed by even a non-engineer person or even a person who knows something about reasonable education qualification. And for that purpose we have evolved reinforced this ring for design of the slab. In this, different options have been given. You have to simply rotate the ring and take out to the appropriate locations, indicating minimum size of your rooms in width and length. After adopting appropriate slots, it gives me an information what should be the thickness of the slab, what should be the reinforcement you have to provide along the shorter direction, along the longer direction, and as a negative reinforcement. So this contribution again made easy for even a mason for selection of appropriate reinforcement detailing and detailing for construction of RCC slabs. So this again further minimizes unnecessary extra reinforcement, which normally you can see in the construction when you visit sites. People are providing extremely large amount of thickness, more amount of 10-12 mm dia bars in even 3 meter span for residential building. So that is not correct. So this is a very great advantage, and we can contribute through this to the economy and sustainability of the country as a whole. In reduction by selection appropriate design approach, by reducing the use of cement, concrete, and the steel in construction process without compromising the quality and the safety of. Now you can have a quick look on the pictorial look, rather, the construction methodology which is to be adopted for confined masonry buildings, which is basically cost-effective, seismic resistant. And in this, I'm showing the strip footing strip foundation we are providing for the construction of masonry building, confined masonry. So this is the, after laying the PCC, you have to provide the type column reinforcement. In addition to that, the appropriate foundation system, and then provide the masonry up to certain height by leaving the grooves, and then pouring the shuttering and pouring the concrete, and then the bond beam reinforcement, and then the masonry work. Once the masonry work is completed in the fashion the way it was explained in this presentation, again at the lintel level we have provided the bond beam, then further the masonry work completed, and then the RCC slab, the way you can the way we have discussed. Once the construction of confined masonry is completed, it looks similar to the RCC frame building, which is quite robust, and even a minor variation will not compromise with the safety of the occupants. So having said, based on this particular investigation, we have developed design guidelines, procedures, and evaluated and proved that the confined masonry is a promising technology, can be adopted even in high seismic zones of the country, that is seismic zone 5 up to 4-story, if constructed properly, and this type of building technology can be adopted for low to medium rise construction. Now, important thing is comparison between the different popular systems, which is also very important thing. So to have a better understanding about the techno-economical perspective, a comparison has been carried out between URM, RM, CM, and in RCC frame structures with infill masonry in terms of load path, behavior under vertical and lateral load, design effort, vulnerability, earthquake vulnerability. In all the perspective, confined masonry proved again having an edge over all the existing technology. From constructability point of view, level of difficulty, sequence of construction, again it is quite low. From quality control point of view, very low to medium quality control assurance is required in case of confined masonry when compared with the your high tech buildings like RCC frames with infill masonry. Now, important aspect is cost. When you compare the cost aspect, confined masonry are relatively 40% cheaper than the RCC frame buildings with infill masonry, and it is around 3 to 4% costlier than unreinforced masonry, and 2% costlier than reinforced masonry. With this comparison, and this particular comparison has been made based on extensive estimation and costing carried out on confined masonry of different typology in different region. Based on that, we have evolved the technical document on confined masonry, which is available in our CBRA website. Apart from that, to have an ease in construction process, particularly for the EWS houses, we have created an atlas, which is which embraces 25 different alternative architectural designs of EWS houses with its structural design and detailing for confined masonry. It is classified in different sections, like when you have to construct up to 1-story, 2-story, 3-story wise, and in seismic zone wise, you can appropriately select appropriate alternative as per your selected architectural plan, and everything has been jotted down in this particular book, that is on structural design and detailing for confined masonry of EWS houses. So again, from implementation point of view, to inculcate the good construction practices day in and day out in the construction process, we have brought out the good construction practices guidelines, which again can be downloaded from CBRI website. To conclude, I should say the tremendous progress towards the seismic safety has been made in the country. We are still developing country, but we are not behind any developed country in terms of technical expertise, knowledge, and Indian seismic code is concerned. As far as earthquake resistant design is concerned, we have to think about again about these codes, although the caters about the new construction, but definitely it is a great challenge about the existing buildings. If they are vulnerable, this is not designed as per the relevant standards, calls for retrofitting, and for that purpose, all the alternative options which has been spelled out in this particular presentations can be adopted for making existing seismic vulnerable buildings to retrofit after retrofitting a robust building. We should always take all kinds of disasters as a window of opportunity, whether it is a COVID or earthquake or any of kind. So that is, for that purpose, it is we need to plan our things properly and construct the things and maintain the our structures properly. Then only we will be achieve real life safety, serviceability, durability, economical and durable housing systems, because the truth says that the earthquake do not kill the people. It is the man in his roles as a builder or different stakeholders who kills the people. And towards a new paradigm, we have to think big and think holistically to address the questions in an appropriate fashion. And for that purpose, you need to improve upon your imagination, which has been done by our ancestors, politicians. You can see this is the 2001 Dubai, and this is the 2020 Dubai. When they can change, why not we? We can also change. And but only thing, whatever you do, you have to keep in mind the common sense. In this particular picture, you have been asked to do any work very fastly, but when doing simple speedy in the construction doesn't need compromise with the system. Do not cooperate with each other. Please understand cooperation. If you will lead between the different stakeholders, you will lead to a better structural system. In this particular slides, you can see in hurry of speed, they have started laying a railway line. Different teams were involved, poor coordination, poor cooperation between the team. They are leading to this kind of a problem and ultimately fighting. So this should not happen, and that's why I always say that never underestimate the word common sense, because it reveals itself. It just waits for the cremation. If not done, this is a scenario of cremation only. So remember, we want to get civilized, modernized, globalized, but first we need to be a safe, resilient, and robust structures. This is the journey through life, and this is how we have to give birth to the new generations also in terms of their technical competence is concerned. So thank you very much for your kind attention and patience hearing. Now I'm thankful to all the participants for their attention, organizers for inviting me. Now the forum is open for further questions, if any. So thank you so much.
So there are a few questions posted in the chat box.
So I apologize if I have bored you, but it was my duty, so I have done my job. So there are, I think, the several questions on the chat box. It shows that I think I have not bored you. So late in last morning. Mr. Tanvesh has written, can you show the formwork required for confining groove system? We do require a formwork for this. For grooving, you have to just give a projection of 25 to 40 in the brickwork, and different courses at the interfaces of the tie column and masonry, particularly at the end of the masonry walls. Next question was from Mr. Ravi Kumar. Among strength, stiffness, degradation, energy dissipation, absorption, ductility, which one is primary parameter on best performance? All the parameters are very much important, that because we have to see the global behavior of the structural system. All the parameters are important, but if one has to prioritize, lateral strength and stiffness is of paramount importance, followed by stiffness degradation, then other aspects. But next is the question is from Mr. Sridhar. Done very exhaustive investigations. Thank you, Sridhar. Suhasini Madhigar, great work, exhaustive experimenters. Thank you. Setu Madhav, feedback form. Very informative. Thank you. Ravi, among the again, the Ravi has spelled out the same question. I have answered that. So I hope I have answered all the questions which are put on the chat box. If you have any further questions, I'm happy to address. And in the slides also, I have shown you the links. You can go to the link and download the documents on the confined masonry, the design guidelines, good practices.
Good afternoon, sir.
Thank you. Good afternoon.
Yeah, sir. Sir, I have a question, sir. Thank you so much for your actually presentation, and it's very exhaustive, sir. Thank you so much, sir.
Thank you so much. Yeah, please.
I have a question, sir. We do actually do static analysis and dynamic analysis for just on frame structures.
Yes.
In case of masonry structures, when we model it for actually dynamic analysis, like I think we are actually concentrating the mass at the floor and all, having a diaphragm action and all. In that scenario, how will be the deformation, or else how we have to model a masonry building, like just to understand the seismic loading?
If you are dealing, first of all, our code also says whenever you are doing the when you are dealing with the RCC frame structure, you have to model the structure simple as a skeleton. But now again, when you see 1890 2016 last section, that also clearly spelled out that you can make use of the stiffness contribution given by the infill masonry. That is in terms of the equivalent diagonal strut, and for that purpose you need to calculate the WD, width of the means infill masonry walls. You have to express in terms of a diagonal strut RC element having the thickness equivalent to the thickness of the wall, and the depth you need to calculate based on the formulations given in the code. Also, you can refer for the details the book given by Manish Shekhande and Pankaj Agrawal. So in that also one section provides the computation of equivalent diagonal strut masonry infills with and without openings. So if you calculate the WD, you have to model this diagonal strut in the similar fashion as a bar element, and only thing is at the ends you have to put as a pin jointed. It should not be fixed or otherwise. So you have to be very particular that it should be a pin jointed phenomena. It should be in both the directions, and WD will be given by that particular equation. Now, so that's how you will encounter the RCC frame structure design. And contribution of masonry infills in RCC frames. Now the question lies which kind of analysis you should go for when you are dealing with the when you want to go for the performance-based design for RCC frame structures. You need to go for the linear static analysis, then response spectra, then non-linear analysis. And if it is a very, very important structure like hospital buildings or schools, or community centers or important building class in seismic zone 5, in that case, you need to go for the time history analysis as well. When you go for the time history analysis, which is a non-linear dynamic analysis, one has to be for that purpose again a reference has to be made as per ASTM 2000 ASTM 14 ASTM 41 2030. In that you have to select very judiciously the time histories, minimum 3 time histories you need to select. Time whenever you are selecting the time history, you have to be you have to look into the geographical geotechnical conditions where the event occurred and from where you are picking that particular time history, and vis-a-vis whatever the buildings you are designing, what is the geotechnical conditions therein. So this is as regards to the RCC frame structures is concerned. When you are talking about the masonry buildings or confined masonry or reinforced masonry buildings, in this you are not expected to perform the non-linear dynamic or time history analysis. Even the linear static analysis is quite good. And for again in the analysis, if you are adopting what tools you are adopting, I don't know, but if you are doing the finite element analysis, if I can say, that for the masonry buildings you can do the micro modeling, in which you have to model the masonry and mortars also, but it will be computationally very expensive, and if given a building on a full scale, it will be very computationally expensive things. So you can make use of instead of micro modeling, you can adopt the macro modeling, in which the masonry can be modeled as a plane strain element and homogeneous material, and wherever the your type columns are there, that can be modeled as a again as a solid element, and you can further take out the analysis. Linear static analysis is fair enough. Once you do this analysis, I will strongly recommend, don't rely 100% on this numerical results. When you are dealing with the practical problems, you should do your hand calculations, whether it is a RCC frame structures or masonry buildings. That is as a matter of practice and good practice in construction process. Important thing is, while doing so, you should at the end check the compliance, codal compliance as per the table 5 and table 6, and the compliance to the masonry strength in terms of the compressive stresses, shear stresses, overturning, torsional and irregularity and stiffness distribution as given in our code IS 1893 and 1905. So I hope I have addressed.
Sir, one small doubt.
Thank you,
Sir,
sir.
good afternoon. Hello.
Thank you.
Shall I finish, sir? One last thing.
Sir,
yeah, please.
Yes, sir. Sir, this when we are having this masonry, confined masonry, what we call, do we have this diaphragm action with the slab, sir? Because slab thickness
yes. Because when you are going for a RCC slab, so definitely you will have a diaphragm action. You can model this RCC slab also, plane strain element, and you can create the diaphragm action, not an issue. And that's why I have mentioned that when you are providing the RCC slab, which is creating the rigid diaphragm action, you need not have to provide the bond beam at the roof, but you need to provide this bond beam at the lintel, sill, or sill level or gable roofs, whatever the conditions may be.
Okay. Thank you, sir. Thank you, sir.
Thank you. Yeah.
sir, there's one last doubt. Can I ask you?
Please.
Yeah, sir, this is an extension of my previous question. Myself, Kumar from Pondicherry Engineering College.
Please.
My doubt is, sir, I'm actually working on a beam column joint, performance of a beam column joint in earthquake zones. So in that case, for example, I'm using 3 different detailings work. But for that, I'm using the reverse cyclic loading condition using as per ACI codes, test procedure and all. In that, I got the parameters of stiffness, strength, and energy dissipation and ductility. Everything I calculated. But if I use XYZ, for example, XYZ 3 category if I taken, X in the case it gives good in a stiffness category, is give a higher value. In another one it's showing for a Y is showing a good ductility. Z showing compared to other one it's showing good strength. So which one I should select as the best one, sir? Of course, three are giving best result.
No, I didn't understand your question. You have done exercise fine. You have got the result very good. What exactly you want to know from me?
Among these three, which one should I consider first?
Huh?
That's a doubt, sir.
Yes, yes.
Yes, sir. Sorry, sir. Yes, sir. I want, sir. Actually, three parameters I have selected. I have calculated for all the detailing work which are proposed. But among these three things, if I get the ductility highest for one specimen, for another specimen I got good in stiffness, for other specimen I got good result in strength.
No, you
So
need
if
to. You
among
first of all, you should have a set of specimen. Not as a single specimen will give you a correct picture. There could be a possibility of some errors in data acquisition or
yes, sir.
experiment or something.
For each set I did two, sir. For example, I taken for X two sets I had done.
So
Y also I did two.
then you have to see, you have to do the proper benchmarking. That is what I want to mention. Benchmarking should be done properly. And uniform procedure you need to apply. And normally when uniformity exists in terms of experimental setup, then the specimen, normally you will give a very good comparison between different data what you acquire. For that purpose, I don't know, we have to see the result in detail first of all before any comment on your observation or your data. For if you need further information, you can refer my one of the paper which is published in Structural Concrete on the beam column joints with the different headed bars. So in that also we have given a very good comparison with precast and in situ and all those things. So strength, stiffness, ductility, deformability, energy dissipation capacity, stiffness degradation are the important parameters one has to take into account. It may so happen that 5 to 10% variation of data results in the two different specimens you can get in even from the experimental or numerical model, but that is what expected. In generally the experimental results give higher data, higher values as compared with the numerical. That again depends. It cannot be generalized, but trend should be uniform.
Yes, sir. Yes, sir. Okay, sir. Thank you, sir. Thank you very much. I'll mail you, sir, regarding your paper. I want to check it. I'll just make a request for you, sir. Thank you.
Thank you so much. Thank you. So if everything is okay, then I take your permission to close the session. So thank you so much, and thank you very much, Radha, for joining. I thank the organizers for inviting me and giving me an opportunity. Thank you so much. And in fact, when you are when the questions are coming from different flora and different directions, I would have been very happy to address the questions on the beam column joints, precast buildings, and even on the 3D concrete printing in which I'm working at the moment. So no, not an issue. We can meet sometimes next and deal on the issues related to the prefabricated construction technologies, volumetric construction, 3D concrete printing, so on and so forth, and performance evaluation of different emerging technologies in construction. So thank you so much.
Good afternoon, everyone. I would like to thank Dr. Aditya for taking out time from his busy schedule and enlightening us with with the knowledge. It was a very informative session. So, on behalf of the coordinators and participants, I'm thanking you, sir, for this wonderful session.
Thank you, ma'am. Namaskar. Stay safe.
Okay.
Thank you, sir. Thank you very much for the session.
Our next session will start at 2:15 p.m. All of you use the link which is given in the schedule. Okay. Thank you all.